Hey guys, so for today you just have some practice problems pertaining to systems of equations, solving them with all three methods, with substitution, with elimination, and also by graphing. This, even though it is just some practice, I do want it to go into your notebook so that you can have that to refer back to. The more the better. So this is going to be page 68 and 69. So we're going to flip to that now. I'm only going to do one or two of each to kind of help you out and then allow you the rest of the time today to work on that independently. So let's flip to that page at this time and look at what we have. So the first page, again, all of this is attached to Google Classroom, so you'll just copy it, print it, and glue it into your notebook. If you can't get it printed, you can always complete your work on Kami so that I can see it, but it's going to need to also be in your notebook. So if you have to handwrite that, do it. If you have to wait to get everything printed later, you can save everything that you've done via Kami and then print it with your notations and your writings on it and glue it into your notebook later. And you can always go to public places where they allow you to print and pay a couple bucks for that. It usually doesn't cost much to print a few pages. Or if you have a friend that you know has a printer, you can go to their house. If you need, there's always extra copies up here at the school if you want to wait till the the end of the week to come and get some copies to put in your notebook and then, write it down that way. Do any of that. Whatever you need to do, you can always reach out and let me know. But if you look at these problems, these are just word problems. So the equation isn't given to you algebraically. You have to infer what it's telling you to do with the words. And there's 8 of these kinds of problems. There's 4 up here, which are much simpler. And then down here, they have items that each thing cost. And you've got to set those up the right way. So I'll do one up here and one down here. So for this first one, it says to define what your variables are going to be and set up the equation and solve it. So one's really easy, two's really easy. So I'll set up 3. I'll do this in pencil. So the difference, again, knowing these keywords is going to be super helpful. The sum is addition. So anytime you see sum, it means that you're adding. Difference is subtraction, right? If I say, what's the difference in 6 and 4? You'll say 2 because you did 6 minus 4. If I said, what's the sum of 6 and 2? You should say 8 because you added them together. So the difference between two numbers is 9. We don't know what those numbers are. So it's kind of like saying something minus something is going to be 9, right? The difference. Well, how do you represent a number that you don't know? You make it a letter. And the most common letters that we always use are X and Y. So X minus Y is 9. Some number minus some other number is 9. The difference between the two is 9. Then it says the first number plus twice the other number. Well, if X is the first number here, we're going to say, again, for our second equation, the first number plus twice the other number, 2 of the other ones, is 27. Okay, so if X is our first number and Y is our second number from the first equation that we made, it's telling us to take the first number and add, it says plus 2 of the second number is 27. Whenever you see is, that means that it is equal to, or that is what it is. So that's where the equal sign would go. Now that you have these two equations, you can solve them however you'd like. You can move this X over here and have Y equals X minus 9 once you move your signs all around and substitute Y in. Or since they're stacked on top of each other, you can multiply this whole thing by -1, making this a negative X, positive Y, and a negative 9. And you can cancel your X's out and solve by elimination. So you have options here on how you can solve these, and you have notes on how to do that as well. I'll leave that there. I don't want to do too much of this for you. If we look down here at these tend to be a bit harder because they have things that there's more to them. There's not just a number. It's telling you 2 different items and then a total amount. So I'm going to do 13 because it's probably going to cause you guys the most trouble. So if we look at the information that we have, it says a group of 40 children attended a baseball game on a field trip. Each child received either a hot dog or a bag of popcorn. So we can make our hot dogs be X's and our bag of popcorns be Y's. So I'm just going to go ahead and kind of mark that on my paper. Hot dogs were $2.25 and popcorn was $1.75. So they're telling us what each one cost and a total amount. So we know a total is going to go after the equal sign. But it wants to know how many hot dogs and bags of popcorns were purchased. So the first thing I'm going to do is, if I know the prices and the total, I'm going to set that up. So we said hot dogs were X's. So $2.25 for hot dogs plus $1.75 for popcorn is going to be a total of $83.50. So the X's represent the hot dogs and the Y's represent the popcorns. So if hot dogs are $2.25 per hot dog, you would put however many hot dogs you're going to buy right here, right? So if I have $2.25 and I only buy one hot dog, that would be $2.25 times 1. If I buy 2 hot dogs, that would be $2.25 times 2. So I'm taking the total and I'm timesing it by however many I have or I'm purchasing. $1.75 is the price for popcorn, and however many popcorns you buy goes right here. So if I buy 1 popcorn, it's $1.75 times 1. If I buy 2 popcorns, it's $1.75 times 2. So the X and the Y represent the hot dogs and the popcorns. And here's our total price. Well, in another equation, we have to just put hot dogs and popcorn, and there are 40 kids total. And I know this because it says up top, a group of 40 children attend a baseball game. Each child receives either a hot dog or a bag of popcorn. So they either get 1 hot dog or 1 popcorn, and there's going to be a total of 40 of them sold. So you can either have 39 hot dogs and 1 popcorn, because again, there's only 40 kids that get to pick between hot dogs and popcorn. So however many hot dogs plus however many popcorns is going to add up to 40 items. They get one or the other. You could have half the kids get popcorns and half the kids get hot dogs. Who knows? We don't know, but we do know that X's are hot dogs and Y's are popcorns, and we know how much each one cost and the total we spent. So these would be my 2 equations. And then I would set them up either, sorry about the light, either by substitution or elimination. Now to me, I think elimination would be harder with this one because I'd have to multiply one of these equations by 2.25 or by 1.75 to get them to equal the same number, then that's just a lot. When, if I just move this X to the other side, I'll end up having Y equals negative X plus 40. And then I can just plug this in right there and just solve the equation for X, which would then be 2.25X plus 1.75, plug in what we know Y is, equals 83.50. If Y is that, then where the Y is, just put what it is. Put what we know Y equals. And then I would distribute, and as you can see, the only letters that I'm solving for at this point is X. I would combine my X's and move everything away, and then I would know my X. And then because this equation is so simple in the very beginning, once you know what X is, whatever's missing to get you to 40, that's what Y is. I'm not going to do all the work again. I'll let you do that. But these equations, you need to read them and figure out how to set them up. So these are like word problems here. These are a bit more simple, but I know that one was really tough. So I wanted to help set you up for that one. Read everything that you've got and try to figure out, how would this make sense? How would I solve this? Then the last worksheet is 4 graphing problems, which I feel like you guys are going to do wonderful at this because this is just linear equations. We've graphed these a bunch of times. They're already in slope-intercept format for you. So that very first number is your slope, and that back number is your y-intercept. Remember, that's your slope, that's your y-intercept. So if there's no number and it's just a negative symbol, that's -1. And then -1 is also my y-intercept. So I go down to -1 and start here, and a slope of -1 would go down and over, like I'm going downhill. And I would just connect all my dots. I can also keep going this way because I know a linear equation's got a straight line. Okay, and then I would graph this one. I would start at +3 because that's my y-intercept. My slope is -5. Connect those dots as best and straight as you can. I'm pretty horrible at that. And that is your solution. So you need to choose between your answer choices. Do you find that? Do you know what it is? And choose your answer. So for these four, you're just graphing them and finding what your answer is. It's going to be one of the options that you have. So I feel like that's going to be the easier part of today's assignment. These word problems might be a bit harder, but do your best and solve for them. And once you know what X and Y is, plug them back into your original equations and see if it makes sense. And as always, if you have questions, you can email me and let me know.